Alright, this is lesson 82, circles. We're going to be exploring graphing calculators and derive the standard form of a circle. So today's it's just conceptual. You just need to know how things work and where do they get the standard equation from a circle. Okay? So you're not going to be finding like x, you're not going to be taking something and graphing it. You're just going to tell me, you just have to understand the concept, which is a little bit of a different lesson. So, here are the steps for today for deriving the center of a circle. We'll come back to it, but if you're on the video, you should pause it. It's up here on the class. Put c squared. But notice what this bottom formula. What does this bottom formula remind you of? What is this one?
Oh.
What is this one?
Pythagorean Theorem.
Pythagorean Theorem, right? Geometry, right? Even pre-algebra they taught you this, like way back in middle school, right? So, and when do we use the Pythagorean Theorem? Triangles. What was it? What did you say? Right triangles, specifically, right? We can't use it on all triangles. Well, you could technically. You could divvy up the triangle, but so we know that one side squared plus another side squared is going to be equal to the hypotenuse. What letter always represents the hypotenuse? C squared. Okay, that makes sense so far. Okay, so. First thing we're going to do, this is our first problem. Input the following formula into Desmos. Explore what h, k, and r do to the circle. So let's go to Desmos. Open up your Desmos app. Again, today is just an exploration exercise, conceptual lesson, okay? Not really going to be calculating anything. Okay, so we're all going to Desmos. I'll pause my recording so you can catch up. So once you're in Desmos, please write the following. You're going to write r squared. So go down here where it says ABC, and you're going to write r squared equals, open parentheses, x minus h, close parentheses, square that, plus y minus k. Oh, sorry, open parentheses, y minus k squared. Okay. And then it's going to say add slider on all these letters. Let's click all, and it's going to give me all these sliders, okay? And then graph the circle based upon each of these values equal to 1. But what I want you to do is play with these sliders. You can press the play button on the side, or you could just use your fingers to see what happens. And I want you to just take a couple minutes and then even discuss with your neighbor what do each of these letters do to the circle as you adjust them, okay? So take a couple minutes, play with that. This is conceptual. Figure out what do all the letters do, okay? Go. What does R represent, everyone? Makes it bigger or smaller, so it represents what of the circle? The what? The size, or what specifically does R stand for? Radius, right? It's the distance from the center to the side of the circle. You remember that from algebra or geometry, right? Radius. So when I make my radius bigger, my circle gets bigger. It only goes up to 10 here, but we can make it infinitely bigger. Okay? What about H? What does H do? Side to side, left and right. As h gets bigger, what happens to your circle? Moves to the right. As h gets smaller, what happens to your circle? Moves to the left, right? What about k? What does k do? Okay, as k gets bigger, what happens?
Goes up.
As k gets smaller, what happens? Goes down. Does that make sense? Yes or no? Okay, good. So this you need to know those parts, right? Yesterday when I was giving you your homework, x minus h and k, remember these two numbers are always different? What do the h and k represent, though? What of the circle? H and k represent what of the circle?
Center.
The center, right? So when you're doing your homework, you can quickly know this is your center and r is your radius, right? Okay? So today that's the first conceptual thing. Okay, so again, turn your neighbor, tell them what h, k, and r represent one more time, just to repeat that so you remember that. So continuing, the first part of the lesson is just conceptually knowing what h, k, and r do. And whenever you're doing any graphing in math, get to know your graphing calculator. Even on there, you should get to know it if you have like a TI 81, 82, 89, 83, I don't know. There's all sorts of them. Okay? So that's how that works. Okay, any questions on h, k, or r? All right, second thing. All right, how do they figure out this formula? R squared is equal to x minus h squared plus y minus k squared. Okay, how do they figure this out? Well, remember in geometry, remember the distance formula last year at the beginning of the year? Raise your hand if that sounds familiar but you don't remember it. Okay. All right, so let's think about this. I'm going to show you up here. If you look at the center of our circle, we have a point here at 1, 1. Okay? All of the points on my circle, all the way around, there's an infinite amount of points around the circle that I could choose from. Those are always variables. Okay? But let's say I just picked one point to choose. Let's say I picked this one right here. If I were to draw a line from here to here, this represents the radius, right? Okay? But if I were to look at the changes of x and the changes of y, what does that create when I look at the changes of x and the changes of y? What does this look like to you? A right triangle, right? So right triangle should automatically make you think of the what? Pythagorean theorem, right? Does that make sense? So I could pick this point, I could pick any point on this triangle or on this circle, and it's going to create a triangle or a right triangle for me. Even if I were to pick an obscure point, like, let's say I just pick this one right here. Yep. This is also creating a right triangle, okay? We have a leg, and then our radius. What's always staying the same around the circle? The radius, right? Right? So, if the point can change but our radius stays the same, we could use the Pythagorean theorem, okay? So, how do we do that? The first thing you want to do is we have to pick the center point here. Our center point here is 1, 1, okay? And we could pick any point here on the outside. We could pick this point, we could pick this point, we could pick any point here, okay? And these would all be variable points, okay? So how do they figure out what the equation of the circle is? Well, they started with the Pythagorean theorem. C squared is equal to a squared plus b squared. C represents what of the right triangle? What does C represent again? Hypotenuse, right? Hypotenuse is which side? The longest side. Good, okay? Okay, so if I have, let's say this point I pick again, I have a radius, this is my C, right, or my radius, and this is an A, and this is a B. So the distance from here to here is my distance formula from geometry. So, or I could just use my Pythagorean theorem. So we got C squared is equal to changes of x, which is x2 minus x1 squared plus y2 minus y1 squared. Okay? So if I were to have a center of 1, 1, the outside of my circle is always going to be a variable. It doesn't matter which point. So these could be my x2s and x1s, but my center will always be consistent no matter what point I pick. So I'm going to replace x1 and y1 with my center, so c squared is equal to x minus 1 squared plus y minus 1 squared. Okay? What does this represent again in regards to my circle? The radius, right? What did we say our radius was in this example? 5. So let's replace c squared with 5 squared. What's 5 squared, everyone?
25.
25. Isn't this the standard form of the equation of what I would give you for the circle? Okay, do y'all see that connection there? Okay, so again, conceptually, the equation of a circle comes from the Pythagorean theorem. We could derive it by knowing what our hypotenuse is always the same. C squared, or C is 5, so C squared is 25. We can pick our h and k, and then we have our standard form of the equation. Okay, so it's a conceptual thing. It's not. This is not something you're going to be doing. I just need you to understand where it comes from. Okay. So right now, I want you to take a moment, talk with your neighbor, explain how do we figure out the equation of a circle from the Pythagorean theorem. Ready, set,